Alright, so with this lesson, we're going to be talking about matrices, but before we talk about anything, we'd review our prior knowledge with our students, just remembering that they knew the identity, the inverse, the associative property, and the commutative property. Once we're done talking about that, we'd walk right into matrices and take all of those properties we just discussed and now talking about in terms of matrices. For addition, we know our identity matrix is 0, 0, 0, 0. Now that's if it's a 2 by 2 matrix. If it's a 3 by 3 matrix, it could be 0, 0, 0, 0, 0, 0, 0, 0, 0. Multiplication is 1, 0, 0, 1. And then talking about the inverse. For inverse, for our identities, we're still adding the opposite, and we're going to equal the identity. So we're going to add our opposite and get this 0 matrix. For multiplication, we're going to multiply by the inverse, which is this matrix here, and we're always going to still end up with our multiplicative identity. But to find this inverse, we're actually going to have to do a different formula, and so for our inverse matrix, we're going to multiply by 1 over the determinant, which is AD minus BC, and we're going to multiply that by a little bit of change up of the matrix, and then end up with our inverse. And so we would touch on that and how to find that. So now we're going to head to this problem. So I have 2, negative 1, 3, negative 1, and I'm going to multiply that by x, y, z, w. Then we're going to add 2, 4, 1, 7, and we want to get 2, 12, 3, 18. So how are we going to do this? The first thing we're going to do is we want to try and get this problem down as basic as we can. And so we're going to try and get this multiplication problem by itself so that we could solve maybe and get our equations and then solve for our variables. So the first thing I want to do is I want to try and use this here to try and move some stuff around. So I know I want to end up with 0, 0, 0, 0, which is our identity. So in order to do that, I'm going to add the opposite. So here I'm going to add 2 and negative 2, 1 and negative 1, 4 and negative 4, 7 and negative 7. But we know by property of equality, anytime we add something on the left, I also have to add it on the right. So I'm going to add 2 and negative 2, 3 and negative 1, 12 and negative 4, and 18 and negative 7. So by doing this on the left-hand side, we're going to end up with the 0, 0 matrix. And so we know now anything plus its identity is going to be itself. And so we'll be able to be left with this multiplication problem here, and on the right hand side I added my different numbers and got 0, 8, 2, 11. So now we're left with this multiplication problem, and we have 2, negative 1, 3, negative 1, and I have x, y, z, w, and we know this is equal to 0, 8, 2, 11. So how do we multiply? Well, we know we multiply a row by a column, and then a row by a column, and our row by a column, and our last row and our last column. And we are going to do this here, put this down, and so we see I did 2 times x plus negative 1 plus z, and this will be equal to 0. Then I have 2y plus negative 1w, and that's going to be equal to 8. And I have 3x plus negative 1z, that's going to be equal to 2. And then I have 3y plus negative 1w, and that's going to be equal to 11. So we're still kind of stuck here because we have a bunch of unknowns, but at least now, get rid of this, we know we can pull out these 4 equations. And so I took my 2x plus negative 1z, and I know that's equal to 0. And I took our 4 other elements, set them equal to the corresponding element, and got these 4 equations. So now using these 4 equations, we can solve for our missing variables. So see if we can move this over. So we started with our first one, and I took the top 2 functions, and I said I have 3x plus negative z equals 2, and I have 2x plus negative z is equal to 0. Well, if we subtract those, we're going to have negative z minus negative z. I know 2 negatives make a positive, so it's negative z plus z. That's the identity. It'll leave me with just this one x. Then on the right, I'm going to subtract 2 and 0, and I get 2. So now I know x is 2. Well, knowing x is 2, we can plug this into our equation. So I know 2 times 2 plus negative z is going to give me 0. So I know 4 plus negative z is going to give me 0. And once again, we're going to use our inverse property. So I'm going to add the opposite, but I have to add the opposite over here. And so I get to negative z is equal to negative 4, which is equivalent to z being 4. So now I have x is 2, z is 4, and that was using the top two equations. And we're going to do the same thing on the bottom. And so I'm going to subtract these two, find my y, take that y, plug it in, and solve for my w. So doing this, we were able to find all four values, which gives us our answer. I know that x is 2, y is 3, z is 4, and w is -2. So here we were able to find our matrix and know that this is corresponding to the x. Now we always want to check our answer. So what we're saying is we could take that answer here, plug it back into our original matrix, and check and make sure everything works out. So we said we multiply by multiplying a row and a column, a row and a column, row and a column, row and a column. If I do that, I'm going to end up with 0, 8, 2, and 11. Well, now let's add it to 2, 4, 1, and 7 and see if we get 2, 12, 3, and 18. 0 and 2 is going to give me 2. 2 and 1 will give me 3. 8 and 4 will give me 12. And 11 plus 7 is 18. So if we look and see, I end up with my matrix on the left being identical to the matrix on the right. And this is the way that we can use all of our properties that we originally learned for our real numbers, apply them to matrices, and be able to solve doing different types.